Hi folks, this will be our final set of videos for this course. Today I want to talk about drive systems, and a lot of people ask me when I get into this topic is why do I as a woodworker need to know about this stuff? That's a maintenance issue. But the reality is we're going to be working with machines, and machines from time to time will break down, and you need to be able to communicate with your repair person with some knowledge on what is wrong with the machine. You often need to order parts. It's very expensive to bring in a repair person to change a belt on a machine where it's possible something that you could do on your own. So it's very important for you to become familiar with your equipment and have a better understanding of how it actually works. So we're going to start off today, we're going to talk about direct drive systems. And when I talk about direct drive, and that is anywhere where the cutter head or the saw blade is mounted directly onto the drive shaft on the motor. And a good example for that would be a radial arm saw. One of the biggest advantages is that there's almost no torque loss with a direct drive system. The disadvantage for this is that it does take up a fair bit of space in the machine design. It's often very difficult to accommodate the motor inside a housing, so that's where you get machines that are expanded in size. So there's, like I said, there's almost no torque loss. You have restrictions on machine design. One of the biggest issues that we have with direct drive systems is speed control. In order to control that speed, we have to put some type of a limiter on the motor, which basically just drives up the cost of that machine. The other thing we run into is if you have a maintenance issue and you have to remove that motor, you have an issue with motor replacement and everything has to get realigned. We ran into that with our radial arm saw this past semester when we had some problems there, and Kirk had to pull that out. I wasn't even aware that that was a direct drive system. I thought it was a belt drive. When he pulled it out, it was a direct drive. The blade was mounted directly on the shaft. That shaft was about 3 feet long, and it's turned into a bit of a costly affair in order to get that repair made on that machine. So hopefully when we get back together soon, that will be corrected. Machines that use direct drives, I've already mentioned the radial arm saw, inverted routers, some overhead routers, and some table saws might have a direct drive, and there's a number of portable power tools that will have a direct drive system built into it. The other system that we should be familiar with, and that is the belt drive system. It is the most common drive system in the woodworking industry, and that's because of the cost. It's cost effective. It's not that restrictive as far as getting the drive system into a tight area. As long as you can fit a belt in onto a pulley, you're usually good to go. There's two main types of drive system, belt drive systems, and that's going to be the V belt and the flat belt. The V belt, we've got a picture of it here. It actually started in the 1920s. We have synthetic belts or we have natural belts, and basically they're going to run between two pulleys. So you have your motor that has your drive pulley, and then you have a shaft where that belt extends to, and what you're doing is you're trying to transfer the power from the motor to the shaft on the machine. Interesting, a lot of people think that when you're using a V belt that the contact is actually on the bottom side of the belt, when in fact the contact is on the side of the belt, and this is where belts can wear and get damaged if they're not aligned properly. And I've got some size of belts here. We can move ahead there. So a few more things. I've got some belt designs. So you can see the belts are available in a lot of different sizes, and you can get them much larger as this as well, and smaller than this as well. That's a fairly small one. So belts are easy to change. They're easy to change speeds. Simply by changing the size of the pulley, you're changing the speed. They're relatively easy to maintain. They require less space than a flat belt. Vibration may occur at high speeds. It may not run properly on a very small pulley. So you can see here on a belt like that, I can get, they're pretty limited as to the size of the pulley that I can get that to fit. V-belts are used on table saws, joiners, shapers, and so on. If you need a belt that's going to be under a lot of stress, there's also belts that have wire cord reinforcement. And that's a heavy-duty rubber belt, provides superb resistance to the elements with greater flexibility and extended life. So your manufacturer, the machine manufacturer, will specify the type of belt that is on that machine. We can maybe move forward. Some machines may require 2, 3, and 4 V-belts. When V-belts are attached together to make one belt, it's called a vulcanized belt. And I do have a sample of a vulcanized belt, and this looks like it actually looks like a flat belt, but in fact it is a V-belt. And if you look closely, there's a lot of small grooves in here. And rather than run a whole series of narrow belts, what they do is they put one larger belt like that and fuse them all together. So it's got a layer of rubber across the back, and that just reinforces that belt. And that's called a vulcanized belt. There's another type of belt, V-belt, it's called a cog belt. It's sometimes used. They have less slippage, better heat dissipation, and travel around smaller pulleys. And this is a good example of a cog belt. And it looks like you've got a series of cogs on the back sides here, like you do here in the picture. And that is there to give you a little bit better torque. So less slippage because the pulley is actually designed to receive those cogs. So better heat dissipation, and they move around smaller pulleys as well. To change speeds, you normally stop the machine and move the belt to a different pulley. Variable speeds you can change during the operation. We have a couple of machines with variable speed belts, and the one that comes to mind is the lathe. And basically what happens, when you put more tension on that belt, you pull it deeper into the pulley, changing the diameter, and that's how you increase and decrease the speed, by adding more or less tension on that belt. So when you have less tension, the belt runs high on a big pulley, or a larger radius or larger diameter, and it runs at a slower speed. And then as you pull it down inside, it will increase the speed.